Welcome, everyone. Thank you for waiting until the last talk. My name is Gaston. I'm from Argentina, and today we're going to talk about how to work with clean architecture, more about MBBM architecture that we are using nowadays. And of my background, I started coding in Android 6 years ago, and currently I'm working as a senior Android engineer at TriMarket. And I'm also a Google developer expert in Android and Firebase. So let's start with the talk. And there is a funny image that I made about clean architecture or about any architecture. So in this case, we have a common scenario where we have a boss that he's saying we need to define an architecture that will let us scale. So there are some suggestions I have out there, MVP, MBBM, and there is a guy that doesn't know what architecture is, and that's the consequences, So in this talk, we're gonna talk about what is architecture, how to work with MBBM, and let's define architecture by the Google definition. So a software architecture defines the way of working in a system, such as building new models, but it must also give an insight into the type of application it describes. So basically, we have different blocks that we need to connect to each other and communicate between these different models. So in this way, we can just have an application that scales and is easy to maintain and fix any bugs that appears on it. So what are the objectives of having a clean architecture? So when we talk about an architecture, we talk about everything in the app. I mean, when we write anything in the code, we are talking about framework independent. So in this case, we don't. It doesn't apply just in Android. It's a more big scenario that we have for clean architecture. We can use it in every situation and every framework. So the concept is independent of any framework. It's easy to test. So the main goal of having a clean architecture design in our applications is to be easy to test. So we can test each model separate from each other. So it's more easy for us to have some tests on that. It's UI independent, so we separate the UI from all the business logic, and we can maintain the UI as a different model in the app. So for us, it's more easy to concentrate on the business from in one side and in the UI for the other side. It's easy to maintain. This is a really nice perk because doing clean architecture in our project will let us touch the code that we need to touch and maintain more easily than just navigating a whole 2,000 lines class and try to find where is the code that we need to touch. So it's easy to maintain, and this is a really nice perk. It's DB independent, so we can have any database, ORM or anything, and it's really easy also to maintain in this layer that we will talk about in an example after these slides. So it's independent of any external component. So we modularize our application in layers. So each component depends on the nearest layer that it has, and we don't usually use all the layers in one model. And the code reusability is really good. So we can reuse code in different UI fragments, activities, or we can reuse, for example, different interfaces and extend classes in our business logic. So in that part is a really nice perk to have also. So there is this picture is taken from the Uncle Bob books. about clean architecture, and the only valid measurement of code quality is the WTFs per minute. So as you can see in the picture, we can define what is good code and bad code in a code review in a daily meeting. So this was a fun image that I wanted to add. But there is a nice quote about Uncle Bob that says, so if you want to go fast, if you want to get done quickly, if you want your code to be easy to write, make it easy to read. So we need to write code also that is easy for others to read. So in first place, we use clean architecture to define a clean way to write code for us, but also a clean way to let others read our code and understand it. Because the main thing about doing an application with a clean architecture is to think about the team and think about how this code will be read in the future. So we need to also take care for the code in this situation, so we can scale more faster. So there is a new architecture pattern that we will discuss about, is model view model. So this is a new concept introduced by Google to create our applications in Android. It's part of Jetpack architecture. So the Jetpack libraries in Android are a new series of standard components for creating modern applications in Android. And one of them is architecture in Jetpack. So in this time, we are seeing an MBBM pattern that is more likely of an observer pattern. So we're gonna be seeing an example of this. But first, let's talk about how this is how the architecture works on MBBM. So we have this picture in the right. So we have our different models. In this case, the first one is the activity fragment. This is the UI layer we use to define like 4 or 5 layers. There are no specific, I mean, there is no specific way of defining the layers, but there are most used layers that we use in MBBM. For example, the UI layer, where the activities and fragment lives. Then we have the presentation layer, where we have the view models and the live data. And then we have the repository layer that it decides where to pull the data from. And the last layer is the data layer. So we have our data sources that could be maybe room and data source, or we could have a remote data source with Retrofit or Firebase or Amazon Web Services. So in this way, we define our architecture in MBBM with 4 layers, in this case, UI, presentation, repository, and data layer. So what's the advantage of using this MBBM pattern? So we have a more modularized application because our UI does not depend on any business logic in the UI layer. So it's an easy implementation for us. So we can just focus on each part of the application in the separate layers. With separate logic from our view, that's a really nice point, because we don't want our view to get so many logic. Our view just show data to the user, so we don't need any business logic on it. So we can separate it. And it's adaptable to life cycles. So in this case, MBBM introduced something that is really important, that is the view model. And the view model persists the live data's data when a configuration change is being made in the Android app. For example, if we rotate our phone, the content inside the live data will be still there after the rotation, and all the observers, it will be triggered again, and all that live data content is being saved by the view model. So the view model has stop point when the configuration change is about to be done. And then when it returns from the configuration change, we retrieve again the data from the live data. So this is a really nice feature for MBBM, and it's the one that is the best for the architecture. So what's the difference between MBBM and MVP? So we can use both. At this time, there is no, big difference about them. But one big difference that I think is the more important is that in the MBBM pattern, we don't need the view inside of into our view model. So the view model is just the presentation, it lives inside the presentation layer. So the main purpose of the view model is just to manipulate data and send it to the UI. So the UI doesn't know from where the data is being fetched or how the data is being processed. And that's a nice thing. But instead in MVP, we need to reference the view inside the presenter. At this time, the presenter needs to know about the UI to notify changes. That's the data layer is being sent to the presenter. So we can get some, for example, any nulls when we don't, when we forget to detach the view in the onDestroy methods or lifecycle events from the view, so the presenter can crash on the MVP. I think there are some libraries on that now helps that process of killing the view in different lifecycle events. But in the MBBM architecture pattern, we use only an observer for the data in the view model. So our UI just lives with all the life cycle in the UI, and we don't care about sending the view instance into the view model. So that's a really nice thing, and the big difference about these two. So there is an example application that I would like to show. It's cocktail application. So we can just fetch some drinks, and it works with Clean Architecture and MBBM. I will be explaining each layer, and let's see how it works. So let me go to Android Studio, and let me know if we can see the emulator. So I will pop up the application. At this time, the application has sent an API request to a server to fetch these different cocktails. They are margarita cocktails. So at this time, I can just press any of those and just see a brief description about how to make this Tommy's Margarita drink. It's not that much. And I can just save this drink as a favorite if I want, but I will not do it right now. Instead, I will search, for example, for another drink, let's say coffee, and I can just see all the different coffees cocktails that I can do. For example, this one, Jamaican coffee. This is the description of how to make it. And then if I want to save it, I can save this drink. And then later on, I have this heart icon in the toolbar, so I can click it, and I can see this cocktail that I have saved into favorites to see it later. So I can remove the favorite also, and I have no cocktails in my favorites. And I can also, for example, search for another drinks. Example, daiquiri. But this is how the app works, and let's see how this works with Clean Architecture. So let's hope anyone can see this package right here. If not, you can always expand the view on the presentation. So at this time, we will start at the view. So I usually like to start from the model instead and the business logic, but in this case, to understand it better, we will start in the UI part of the architecture. So we define different layers that I spoke about before. So first layer is the UI layer, and we saw that on the slide that we have the activity fragment layer. So we start with the UI layer. The UI layer has two different packages. One package is the cocktail detail that has the cocktail details fragment, where all the details of the drink is lips. For example, this screen is inside this cocktail details fragment right here. And then I have my favorites package, where I have my favorites fragment, where is this favorite screen right here. So this is just a basic way to modularize this UI part. And the main fragment is the main screen that I have, that you can see is this one right here. So let's start about right here, because this is the first screen that the user sees when they open the app. For example, if I click here, it opens the app and it fetches the data and comes to this screen. If you have any questions, you can leave the questions in the Q&A section. I will be glad to answer any of those when the talk finish. But first of all, what we do in the fragment is we need to fetch the data from the server. In this case, we are in the main fragment. So the main fragment just has the UI definition. I mean, we don't do right here the business logic, or we don't fetch anything from the server right here. So in this case, I just have my fragment that just has the view, how it's going to be rendered in the device. So we have a list and a toolbar right here. That's all. Then what we need to do is, after the fragment is being created, we need to fetch the data to the server. And here is where the magic starts. So from MBBM, what we need to fetch the data is just one thing, is the view model. So the view model just will trigger the fetch to the repository, and then the repository will just decide from where this data is coming from. But let's see the path. So after the app initialized, I fetch the cocktail list right here. And then I use this observe into this cocktail lists. And this is because this fetch cocktail list, if I control click on it, it's a live data. So I'm returning a live data. This is from the live data Kotlin extensions. So this is why I can use live data right here for the return type of this variable. So this is a live data, and a live data holds data inside, and we need to emit to the UI these different states of the data. When I tell about emitting data, is we need to notify the UI about the different events that are happening before we get the data, when we get the data, and if we have any failure on getting the data. So first of all, when I fetch, I observe this live data. And this is a very important thing. If we are using fragments, we need to view the lifecycle owner of the fragment. Because if you have been working with observable pattern, you need to detach the observers when the lifecycle of the fragment or activity dies. So you don't subscribe the observer again, and you don't emit twice the values to the UI. So this is a really important thing right here, the lifecycle owner. And luckily, we have in Android this extension that is really easy to use. It's just get view lifecycle owner in Java or view lifecycle owner in Kotlin. And with this, we are observing the data. And what we are doing from the view model is we first emit a loading result, and then I catch that loading result right here because I am observing that live data. Then I just I can show the progress bar that something is loading. Then I just do the fetch to the server, and then here is where the repository comes in place. As we talked about before, I was talking about the UI layer, the presentation layer, that is this one, where the main view model lives, and then we have the repository, which decides where the data is coming from. At this place, my presentation layer needs the data to bring to the UI. So I need my repository to handle that fetch operations and bring me that data. Right here, I use the repository inside these fetch cocktail lists, and in the repository, I get a method that it's called get cocktail by name. I pass the cocktail name that I put in the search box before, or as by default, the margarita cocktail, that is the current default one. And then I use a flow to collect every drink that is being fetched from the server. If I have any problem doing this, since this is a coroutine context, will be all the failures will be propagated to the catch block right here. And I can emit a failure to the UI, and then the UI can just get that failure because it's observing that live data and show a toast saying to the user that something wrong happened. If that fetch is successful, we can just go to the resource success right here and just put the data inside the list. And this is being done after the repository gets the data from the server in the view model. So how the repository works. From the main view model, we need to fetch the data in some place. At this time, the view model doesn't know if the data is being fetched from room or local database, or is being fetched from the server. So let's go and control click on get cocktail by name. And let's see where this method is implemented. As we can see, we have been using an interface for this, so we can abstract the logic on this. And this is where the code reusability comes in place when we were talking about that in the slides. So I can reuse this interface in another data source if I want. Sorry, in another repository if I want. So I can reuse these different suspend methods right here. So if I go to the implementation of get cocktail by name, I go to my repository, and then I just implement that interface, the cocktail repository interface, and then I get this method, get cocktail by name. That is the one that I'm using in my view model right here. What this default cocktail repository do is the following. We have two data sources, the network data source that will fetch data from the server, and the local data source that will be fetching data from our local database. As we saw in the slides, let me just pop them up again. As we saw right here in the slides, in the repository layer right here, we can decide if we want to fetch the data from our local database or a remote database. There is a concept for the repository pattern that is a single source of truth. And that one says that we always should fetch the data from a local storage. But that data should be always updated with the latest remote data possible. There are different strategies for updating the local data with the latest remote data. I have implemented the easiest one, that is just fetching the data from the web and then just place it inside the room, and then the next call will also always fetch this one, but in the background we will be also fetching the remote data. So in this case, sorry, I have this method inside my repository. The first thing that it will offer to my view model is the data that I have in my local data source. So my catch cocktails. In this case, the cocktails that are being saved in room. After that, I use the network data source to make a call to the server, get the cocktails by this name, and I use the same resource success and resource failure to get those results from the server. If the resource is success, I will save those cocktails into my local database and then offer those local database cocktails to my UI. So I'm always saving the latest response from the server into my local database, and I am offering that to the UI. So we always work with fresh data from our local data source. If this fetch to the network fails, I always offer the latest results in my local data source. This could be empty, but it's better to offer to the user something to see instead of popping an error. For example, if we try to make a fetch, we can still offer the previous data before the fetch, and if we have a failure, we can just still have that data instead of popping an error and the user can't go back to the previous state. So this is a really good way to always keep the user with data. And then we just close the channel for this flow. And this is another topic that I don't want to go into so much, but the only thing that this method does is offering data from the local data source, fetching something from some data from the network, and then offering that data that it lives in the local data source that we save. So how the data source work? So this is the latest layer. As we can see right here, we have two data sources, the local data source and the remote data source. In this case, we are in the repository, and the repository knows about these two. So we know about Room, and we know about the web service, in this case, or API. So we have a network data source and a local data source. So let's go to the code. So our repository has the network and the local data source. So let's see how they work. So if I go to the network data source, this data source just have a web service that just fetch data to the server, and this is being done with retrofit. So my web service just has all the calls to the server. In this case, it's just one that just searches for the cocktails by name and returns a JSON. And that JSON is being converted by a JSON converter that is JSON, deserialized with the library of retrofit. All of this is being done by coroutines, so all the asynchronous work is seen like a sequential work. So any async operation that we do right here, we are not using any callback because we are waiting for the response before going to the other line of the code. So if something fails right here that we have this coroutine, we'll be bringing the error back to the view model. And then let's see how the local data source work. Let's go to the repository, and the local data source is the same exact thing that the network data source. What we have instead of a web service is a DAO, data access object, that it defines how to save and how to get the data into Room. So these are the methods that we have for fetching data into our local database and saving, deleting, and anything. It's a really straightforward implementation for Room with these annotations right here. They are really, really nice. And the cool thing about this is if we miss any names on the annotation, it will be marked in the time we are writing our sentence right here. So this is not at runtime that could fail in our app and make a crash, but instead we are having it at compile time right here. So this is a really nice thing about these annotations right here for Room. So in the local data source, we only have the methods to save data. We use the cocktail DAO to retrieve that data and return it to the repository. Then our repository offers that data to the view model. So the view model get that data right here and emit that data to the UI. When I emit that data to the UI, the UI right here is just waiting for that data, and since that data is being fetched, I came right here and I populate my list. So as we can see, the UI just shows data, and the other components just connect each other to conform all these different models that work together, but each model knows about the closest model that it has. For example, the UI only knows about the view model. The view model only knows about the repository, and the repository only knows about the data sources. So we don't couple all the models together, but instead we decouple the models, and they work by themselves. So in the future, if we have any problem inside the repository, we just need to fix the problems right here, and we don't need to touch any UI logic, any view model logic, or any data source logic. In this case, it's easy to maintain because this code is more readable for the team and for us. And if we have any problem on our code, we can fix it right away without breaking any other models. So as I was talking about all of these classes, I went from the UI package right here to the presentation that I have my view model. Then I have the domain layer where the repository lives. We can call it also repository if we want, but I think domain is a better name for this. We can also have use cases with the repositories. There are plenty of different types of implementing these architectures with interactors and other things. As we can see, I am using also Dagger. Yeah, it's kind of the same thing, but I'm using Hilt for dependency injection. And this is the domain layer where the repository lives. Then I have my last layer, that is the data layer, that we have the local data source and the remote data source or network data source. So these four are all the layers that you need to create a clean Android application. Then these other libraries are more of a helper libraries to modularize better the application. In this case, core, we can have the base view holders, and in this case, it's just a helper class that I use in all my lists, so I can just extend from base view holder and reuse it from where I want. Then we have application where we have all our Dagger implementation. For example, the dependency injection comes from here, and we can provide each dependency to our view. So this is all done by Hilt, and it's also really straightforward with all the annotations, and they did a really great job on this one. So it's a really nice thing to look at. And then we have the util classes. We can have extension functions right here, inline functions, and that's pretty much all. So to finish up the presentation, I would like to let's do full screen. I would like to say some recommendations for those who are willing to deep dive into architecture. So there is a awesome talk about Robert C. Martin. So if you don't know who Robert C. Martin is, he's a great guy. I mean, he wrote many books about clean architecture, and not about just Android architecture. There is no books about Android architecture by him, but his books are more like for open your mind on clean architecture, how to work clean, how to name variables the right way. how to open your mind on creating good software and scalable software that can work in whatever team. So this is a great talk. You can search about Robert C. Martin, Clean Architecture and Design. This is the talk that is on YouTube. Then I have read these two books that I will recommend from him. This is Clean Code, and this book is big. I mean, it has lots of examples, but I know it's outdated and maybe it's an old book, but it's a really nice heads off for starting with clean architecture. So there are plenty of examples, plenty of good content that we can read, and we can just work our head around all of those problems. And it really opens your mind, and it's really a really nice book. So the other one is more likely how to work professional with your code, how to estimate your work decisions, and this book is more about recommendations for professional life, but it also talks about some clean code examples, so and different situations in our daily basis. This is a really nice book also. And then these are some helpful links. So if you want to take a screenshot right here, I will be sharing the slides with the hosts, but there are the links. This is the applications, the GitHub, and the Android architecture guide. This is a really nice first step to introduce you to Android architecture by the official developers Jetpack guide. So it's a really nice. And the last is a YouTube channel that I have. It's in Spanish right now currently, but it also has all these cocktail application videos. I mean, I made a whole series of the videos of the cocktail application, so you can find it on that channel. So thank you so much, and I will be reading some questions. So the first one is a really nice question. How would you approach refactoring an MVP project to MBBM? First of all, I will get rid of the view inside the presenter in the MVP, and that's all. I mean, if you see MBBM and MVP, they are almost the same thing, but the presentation layer change. In MBBM, you have an observer pattern, so you don't depend on the UI in the presenter, in this case, the view model. But in the MVP, you depend on the UI. So you need to have an instance of the view inside the presenter to update the view. First of all, what I will do is get rid of the view inside the presenter, then just extend from view model, and then just deliver that data with live data into my UI. Then the UI just observes that data in the view model, and that's all that you need. All the other logic, the business logic, is keeps the same, and that's a powerful thing about clean architecture in a whole way. You don't need to change all your code base to just implement a new thing like MBBM, for example. Just change the presentation layer, move your UI logic to the UI layer, and then the presentation should do the work with the view model. So the core package is more, I think it's more used for base classes or abstract classes that are more of the core of the application. I mean, when you reuse tons of abstract classes, or you extend, for example, this base fragment, base activity, base view holders, I think they are part of the core of the application, because you use it often in different classes. I'm still wrapping my head around the different package names, because there are so many different ways to name them, and I usually stick with always the same names: core, utils, application. But the other layers, domain, UI, data, and presentation, are always the same. So what about MVI, model view intent? I think it is. I heard it works better with Jetpack Compose. So I have worked with Jetpack Compose a little bit. It's a really nice. It's a really nice thing. I mean, I maybe in the future it can replace the XML, but in the short term, I don't think it will do. About the MBI pattern, I have not used it recently, or I have never used it before. I have heard of it, but I have used only MVC, MVP, and MBBM. If you see all these different architectures, they all rely on the difference between the presentation layer. I think it all relies on the presentation layer, because the other layers, the data and repository layers, are always the same. I mean, they never change. You can have more interfaces and you can abstract more those layers, but I think the presentation layer is the one that changes more in the long term. And they did a really nice job on MBBM, because we don't need to rely on the view. I don't know about model view intent, um, but yeah, they are doing a really nice work on these different kind of architectures. So what conditions do you think should be met before adding a domain layer? For a new project, starting with presentation, domain, and data can be over engineering. So let me just get it right. So let me think. So before adding a domain layer, so there are different ways you can approach it without over engineering the application. I mean, this concept of having different package names like data, presentation, UI, domain, and so on relies more on having these different um, models to be connected by each other. Um, but I think the condition that you should be looking for if you need a domain layer is when you have your data layer that needs to deliver any data to the presentation, you will need a man in the middle of those two. And I think the domain layer is the one that is responsible of that. And if you don't need a domain layer to interact with your view model or your presenter, for example, if you go directly from the view model to the data layer, you can use you don't need to use the domain layer. But think about this: if you don't have the domain layer and you go from the view model to the data source instead, um, what happens, for example, in the domain layer or the repository when you need to decide from where to pull the data? In that case, you will be doing the logic inside the view model. So you will be doing the logic of fetching the data from the local data source or the network data source in the view model, instead of delivering that logic into another component that lives inside the domain layer or the repository layer. I think that's the condition that I think should be the best for adding the domain layer, because you need that kind of, it's a one step more abstraction, but it helps you decide from where the data should come from. so your real model just knows about data coming from, but it doesn't know about the logic to fetch that data. I don't know if that answered your question, but yeah, I think so. So okay, thank you so much, everyone, to attend. And nice, cool. Thank you so much.
Awesome. Thank you, sir. That was excellent.